Hey, hi everyone. Uh, let's wait for a few minutes. Let people join and we'll start. Uh, okay, so let's start the session. Uh, so before we start the session, yeah, let's have a quick introduction and let's talk about the event, like what the session is going to be about. Uh, just give me a second. Okay, sorry. Uh, so, okay, so for a quick introduction, I guess probably some of you already knows me. I'm Rajesh. I have around 6 years of experience, building backend applications as well as Android applications. My primary domain is Android, and I love to play with the Android thing. Uh, Now, today, what we are going to do is uh, let me share my screen and Okay, just give me a thumbs up if it's visible. I think you can do a thumbs up, right? Can someone of you react or something? Cool. So what we are going to do is we are going to understand how the code generation works. So we will see what is the code generation. So this is the event, and this is the event save. If anyone of your friends wants to join, you can just give them the invite link. And by the way, this is shared in both the off topic community groups as well. So this is something we are going to discuss. And before we start, let me just tell you that if you have any questions at all, feel free to raise your hand. I'll come to you. Like I'll take the questions occasionally. And at the end of the sessions, if you have any questions, feel free to raise your hand. Keep it raised until I answer a question, so I can come to you turn by turn. Okay, so uh, the title is clear. Let's understand what exactly we are going to do in today's session. So what we usually do is in an Android project we write a code, write something like, for example, say I have created a simple project. You have your main activity, which is annotated with applications is annotated with Hilt Android application. I assume you are already familiar with the Hilt and a Kotlin. Okay, so I'm not going into it, and I assume you are already familiar with the Hilt dependency injection. Do we have anyone who don't know the Hilt? They have no idea what the Hilt is? I assume all of you has, right? Cool. So what we are going to do is I'll first show you the manual example and like how we can automate the whole thing. So the motive of this session is to write the code that generate other codes. Okay, we usually write a code, something like one, do something, blah blah blah. Okay, so we write the code ourselves, right? And then we call it. But today what we are going to do is we will write the code that will write another code. Okay, and that will really automate the manual laborious process that we have. So what I did, the use case is, let's say I have an application annotated with Hilt Android application. Okay, and then I have the main activity where I am getting the view, and I have one view model, something like this. And then I have my repository. I have an implementation and the actual repository. Let me just move it here. So it would be easier for you for remove it. Okay, so I have one repository, and we use interface and implementation pattern, right? So this is the interface my repository. There is this function called a do something. This is the concrete implementation of this repository, which implements this interface and override this method and just do one thing, that is logging the statement. There is one logging statement, nothing else. Okay, as simple as that. Then we are taking this repository as view inside a view model. Okay, and then we have this do something function in the view model that tags this repository. Okay, so and then the main activity we are getting the my view model using the activity ktx api android x dot activity, and by calling the view models function. Okay, and then we are calling the view model dot do something, as simple as that. Okay, now you know that if you have the interface and the implementation, and if you are injecting the interface in a view model, you need to go and tell the Hilt to bind this interface with the implementation, right? You need to create a Hilt module that binds this interface with the implementation. So we have created a sample module, and we are installing it into singleton component. This is an abstract class, and there should be an abstract function which takes implementation as a parameter and returns the interface. And you need to annotate with @bind. What does this mean? Is this lines will tell the Hills that we this implementation is the concrete implementation of this interface. We want to bind this interface with this implementation. So this will do one thing. Whenever you inject a interface, Hilt will go read this code, and Hilt will enter your implementation. That is this class. Okay, as a dependency. If I just run these things, you see on the on start button, this things will be printed. And by the way, this is nothing, this will just print the class name. Okay, so when the activity starts, it will call this view model functions, and then it will call this repo functions, and this will just do log.d. That is the use case. Okay, let's see. Yes, so do something from my repository impl is printed. So this is the use case, a pretty standard use case. Okay, everyone is able to understood up to this point. Any question? Just raise your hand and I'll get back to you. Uh, any questions? Any concerns? Okay, cool. Since everything is good. Okay, ठीक है. So this is the pretty standard use case that we wanted to automate. Now what we want to do here is let's think about this way. Hide it. Okay, now let's think in this way. For example, you have this interface and you have this implementation. Uh, now we don't care about these methods and what this method body is, whether it's 100 lines of code or 1,000 lines of code. We don't care. What we really care is for this session is you have one interface and you have one implementation. So what you need to do, you need to create a module and bind each of these things, right? You need to, let's say, for example, you have uh, 20 repository with their interface and implementation. You need to go bind all the 20 repository implementation with their interface, right? So that is a laborious task. What if you have 100 repositories? You need to go and bind each of them one by one, right? So that is something we don't want to do because this is a laborious task, and as a developer we really don't want to do these things. What we want to do is we want to automate this whole process of binding. Okay, so the way we are going to do these things is using the annotation processor. Annotation processor is what I'll explain. So whenever for example, you have used these libraries like a Hilt or a Room or Retrofit. So whenever you want to do something, what you do is you annotate your class or functions with something. For example, when you use a Hilt, you use Android entry point to indicate this. Okay, this is the entry point. You annotate them with the view model to indicate that okay, this is a view model. Okay, then you go to the module itself and you see this is an abstract class. So there is this module annotation is written. This is what? This is an annotation. Okay. So what happens is when you add these annotations, what Hilt will do is Hilt will generate additional code at the compilation time that will actually let the Hilt know that okay, if someone asks me for repository, I need to go give them the repository implementation. In case of a room database, you have these things called DAO, right? Whenever you have a class, something like say class use the DAO. You have a DAO, then you annotate with at the DAO. So this, so what Room will do is Room will generate some code based on this annotation. Okay, Room will process this annotation, and whatever the methods you have wrote inside the DAO class, Room will generate the code for it. In case of a retrofit, what you will do is let's say you have this interface called my API. So you have this functions called a get user. Okay, and let's say it returns a list of the user and say it is a suspending function. So what you will do is you write something like get annotations and then user. So this get is what? I mean, retrofit is not. I have not included it as a dependency, so it's error. But you got the idea, right? You write something like this. So when you use at the rate get, that means you are using one of the annotation provided by the retrofit. So when you compile the application, retrofit will generate some sort of a code that will actually implement this interface, and it will implement this method, and it will go make the network request on this URL, and then it will return you a list of the users. So this whole thing is happening without you even noticing, right? What you do is you just write these things. retro will Retrofit will take care of all of these things, implementing this interface, implementing this method, making the actual network call, and returning you the result. It involves a lot of process, right? I mean, making a network request is not a single thing. It involves a lot of process. like caching and all those things. So this annotations is doing this job for you. That means as a developer, you don't even know. But no more today we are going to learn how these things happen. Okay, like how the libraries are generating the code, and what if I want to create my own annotation. So we will take an example of these things. So what we are going to do is we are going to uh, write an annotation, and whenever we use these annotations on, say, for example, any implementation, we are just going with one example. Annotation processing has a countless applications. You just think of it and you build it. Okay, it has a countless of applications. For our concern, what we are going to do is we are going to write an annotation that we can add on top of any implementation class, and then we will pass the interface that this class is implementing. Then based on this information, we will generate a Hilt binding module. Okay, this code is something that we wrote manually as of now, but we want to automate this whole process. Okay, yeah, for example, adding the annotations, and once user add the annotations on their class, we will generate the binding information. So what user needs to do, if they have 1,000 repository, they just need one annotation on top of their repository class. Okay, no more writing the binding code manually. This is something we want to achieve using the annotation processor. Okay, so the requirement is clear for everyone what we are going to do. Any question, any concern? Just a thumbs up would say that, okay, you are good. Awesome. And folks, please feel free to ask questions if you have. Let's make it interactive, because I really don't want to make it a one-sided session. So if you have a question, just raise your hand, and I'll get back to you at any point. Uh, ठीक है, Arpit, yes, please. Okay, I'll give you mic access maybe. Yes. Sorry, I need to give it manually. Yes, Arpit, please.
Yeah, thank you, Rajesh, and thank you for hosting this session. So I just had a quick question regarding the annotation. So, like, what are the limitations for the annotations?
Uh, okay, so if you talk about the limitation, uh, annotation allows you to generate the code. So basically, to talk a bit on the history part, there was this Java, right? So up to this Java 1.5, they had no annotation. So since the Java 1.6, they introduced this things called annotation processing. So annotations could be any interface or could be any class that you can add on top of any, say, class or a function or interface or a variable anywhere, and it will do its work accordingly. So if we talk about the annotation processor limitations in general, the things is yeah, this is a good thing. So one thing you need to know is annotation processing happens at the compilation time, right? So it has no access to the runtime code. So all the annotation processing. This is why, see, folks, I'll tell you. So you have heard. I'm deviating a bit, Ankit, from your answer, but it's just part of it. So you may have heard that Dagger is provides the compile time safety, right? Why? Because Dagger use annotation, Dagger and Hilt, whatever. Dagger use annotation. So annotation processing has this limitation that it happens on the compilation time. It cannot run, cannot be done on the runtime. If you want to do something on runtime, you need a reflection. So the and Dagger heavily relies on the annotation. This is the reason Dagger is a compile time dependency injection, and it checks the all these things at the compile time. That is one thing. And other things is, whatever the annotation processor you will run, that will be running inside their own separate JVM. Okay, it will be separate from the main application that is running. So annotation processing will happen, I mean, run in the separate JVM. So this could be two limitations I could point out.
Yeah, thank you for explaining, Rajesh. So one more thing I wanted to add is like, is it true that when we add like annotation, it will also increase the build time? And I also like to know more about like the KSP. What is the KSP and what is the difference between like annotation processor and what's the KSP?
Uh, right. So to answering the first question is if you add the annotation, will it increase the build time? It depends on what you are achieving. Like if you are writing a lot more code and if you are not using the optimization techniques like the one that KSC provides or the Gradle has these things called incremental processing. So if you are not leveraging these things, it may increase the build time. Anyway, if you are doing the annotation processing, it will, I mean, even if the slightly is, it will increase the build time because at the compilation time, it needs to process the annotation. So yeah, it will increase. Plus, the KSP part is something I guess we can keep it at the end of the session. Let's first understand what these things are, and then we can discuss the KSP thing. Okay.
Yeah, that's a good idea. Yeah. Yeah. Another question I had, Rajesh, sorry for interrupting this session, but like the KSP, and I don't know much about the KSP and how it is differ from the annotation.
So yeah, KSP is annotation processor. So whenever you have a Java code, you have some annotations in your Java, you would write something like this, annotation processor, right? So you would pass your dependency inside this annotation processor function in a Gradle. So Java has this annotation processor. Okay, Java has this annotation processor. When the Kotlin was invented, Kotlin had no annotation processor. So to make the symmetry with the Java and to add the annotation processing capability in the Kotlin, a KAPT was introduced. Kotlin annotation processor. KAPT. I believe you have heard about it. The things was KAPT was just acting as an intermediate. It was taking the Kotlin code and generating the annotation processes according to the Java style. So it was acting as an intermediary. It was generating the output that the Java annotation processors can understand. Annotation processor simply means core code, language level code that process the annotation. And KAPT has these limitations. It has a few drawbacks and performance issues was there. So to provide the language level support for the annotation in Kotlin, Google created a KSP, Kotlin Symbol Processing. So KSP is a annotation processor for Kotlin. Okay, that does not need any middleman, and it works solely on the Kotlin level. Like it understands everything that Kotlin does, like for example, suspending functions or inline functions or whatever. It is specially, you can say, designed for the Kotlin. So KSP is what annotation processors are to Java.
Great explanation. Thank you for giving me explanations, Rajesh. This is great.
Yep.
Thank you.
Yep. Awesome. Welcome. And other folks, if you have a question, feel free to ask. Like Arpit, Arpit is very active in all of my sessions. Cool. So let's go and build things. So what we want is we want to generate this whole code based on the annotation. So one thing you need to keep in mind is, and by the way, I'm using version catalog. If any one of you are not aware about this version catalog, it is just a new feature to implement your, your dependencies. This is a Gradle feature. I think I don't need to explain these things. It's just that you were earlier you were writing the dependency here. Now there is a central place to add all of your dependencies. You can just go and check it out. It's not part of the session. Okay, so what we want is we want to add an our own annotation, something like okay, अगर ये लोग भी कर रहे हैं तो अपन अपना क्यों नहीं करें, ठीक है? तो उस मोटिवेशन से let's start building our own annotation. So one thing you need to keep in mind is your annotations and annotation processor should be, in a separate module. Okay, it should be in a separate module. So what you can do is let's go and create a new module for our annotation. Okay. Now this annotation has nothing to do with Android, right? This will just generate some Kotlin code. Like for example, we are not going to use any Android API like context or intent or activity, whatever. This code does not use any Android API, right? So what we are going to do is we are going to create a Java or Kotlin library. Okay. So let's give it a name. annotations. Okay, this is a package name. This is a let class is something we can change it later. Language would be Kotlin, and let's say build configuration is a Kotlin DSL. Yes, that's fine. Okay, so we just created a new module. Inside this module, what we will do is we will, you know, Excel. Let me just reset it. So we are going to have a three module. One module is for annotation. Our second module is for processor, and the third module will be app module. App module is something our applications is. So the annotations will be consumed by the application. Okay, annotations will be consumed by the application. The processors will process the annotations and generate the code that can be used by the application. Okay, this is how it's going to be. This is how it's going to be done. So in the annotation, let's go to main. Let's go to the my class. We don't need a class. So what we can do is we can generate and let's just use annotation class. And let's give it a name, generate binding. This is going to be the name of our annotation, and the name is a generate binding. Now, okay, let me talk from this perspective. So what we are going to do is we want to add this generate binding annotation on top of the repository. Now both of these class are in a separate module, so they have no access to each other. We want this application to have access to annotation module. So we'll just go to the applications build file, and then we'll write something like implementation, and then we'll what implementation? We don't want to implement any third party dependency. We want to take the module from this project only. What is the name of this project? It is the annotations. Okay, the name of this project is annotation itself. That means we want to access all of the code that is written inside this module within the app. Let's sync it and let's see how it goes. Okay, so now if I write something like this, I can see generate binding is available to access in my app module. Okay, this is done. Okay, we created annotation. So now you see this code. So if you want to generate this code, what you will need, this is something we know. It's a static, right? It's a static import. I mean static import, not the static class. This is static import. This is something we can write. What we need is we need the actual class that I mean implementation and the interface. Okay, so what what else remains? The remain is this interface. So somehow we need to provide this interface. I mean, somehow user needs to tell us, right, that which interface they want to bind with this implementation. So what we can do in the generate binding, we can take type as an argument, and the argument would be of a K class. What is the K class? Uh, okay, in Java, you see something like this. For example, you use something like this. My repository says this class, right? What does this represent? This represent something called a class. Okay, it is a class. The name of this class is a class itself. Okay, and it's a generic class. So this represents the class of application at the current running time. So we want to take this, and by the way, these things are the sort of same thing. So we want to access this class when we are processing the annotation. So in the type variable, so similarly, Java has a class, Kotlin has a K class. Okay, it represents a class and provides introspection capabilities. Like what is the name of this class? What is the fully qualified name of this class? What are the members of the class? What is the constructor? Is there any nested class? And what are the type parameters of this class? So basically, all the information that is related to a particular class can be provided using the K class. Okay, in Java it is a class. So we will take a K class as a uh, type parameter. So what we can do in the type class here, we can tell the we can tell the uh, our annotations that okay, I want to bind this repository with my repository, and using this operator you can just use the provide the class. Using this you can provide the instance of the k class. Okay, so now at the annotation processing time, we have access to both of these things, implementation and the class using the type. And this and all the annotations has something called a retention type. So what is a retention? Retention means uh, two things. It needs two things. The first thing is a target. Target means where you want these annotations to be applied. For example, if I use the annotation target dot a class, that means these annotations can apply on a class, on a certain class. If I use it something like, for example, if I use a property, something like a property, and if I see this thing, you see this annotations is no longer valid because it cannot be applied on a class. It can only be applied on a property, that is your variables. So I want to apply it on a class. Okay, so now it is valid on the class. Another thing is there is this thing called a retention type. So what is a retention type? Retention type means how long you want to keep this annotation. So there are three types: a source, binary, and runtime. Source means this annotation will stay in the source code of the application itself, but when you generate the binary or at the runtime, these annotations won't be present there. Binary means annotations is stored in the binary output. That means at the compilation time, this will be visible and it will be stored in the binary output. But when your application is actually running, these annotations won't be visible. That means if someone is using the reflection, these annotations won't be visible. I mean, it will be discarded, sort of. And there is this final type called a runtime. So you want to retain this even in the runtime runtime code as well. So this will be retained in the runtime as well. So this is something you can do, and probably in our case, we don't want it on runtime. We only want it, say, into maybe we can use the binary, right? Or even if you don't specify, it can take the default values. So we just created our own annotation. Okay, if I run these things, nothing will happen because right, we just wrote a simple class. I mean, we did nothing else. So no processing will happen and nothing will happen. But let me just run the application in case, to verify the things are good, and then we will write the annotation processor. Okay, application is running well and good, awesome. Now we want to generate the code using this annotation. So we will write a code that reads these annotations on all of the classes, generate the code, and give it to application. Okay. Before we proceed, any question, any concern, or you folks were able to understand what I just wrote, or it's like what this Rajesh is saying, I don't have any idea at all. Okay, Yarpit, please. Yes.
Yeah, so I just noticed, Rajesh, that the K class is also part of the Reflect API. So is it doing that thing, that runtime? Because we talked about like the annotation is on the compile time thing, right?
Right. Annotations is compile time, but the way, I mean, it is, you know, it represents a class and provides introspection capabilities. Instance of this class are obtainable by the class syntax. So it is part of the Kotlin.reflect, but it represents the actual class. So even you can, accept the class. I mean, accept the class type as a compilation time as well. Even at the compilation time, this will be visible. Even at the runtime, this will be visible. It just represents a class. It just represents a class. Okay, I guess yes. Anyone else? Is the fox shy, or nobody wants to ask any questions, or it's like okay, everything is fine? Yes, I really appreciate the questions in all of my sessions. So please feel free to ask question. Yes, please.
Yeah, it is required to create a module for the or without another module, we can also create annotation.
So usually what you do is for the annotation process, you create one module for say annotations. You have whatever amount of the annotations you have, one, two, three, four, five, six, or 10. Then there is this app module and there is this, this processing module. So usually you keep these things in a separate module so they can be processed in a way the Java can process it in a way independently, because the one module will be running into one JVM and the annotation processing can run into separate instance of the JVM. So we separate them out by the module. Even the K class has expect an actual code multi-platform capabilities in the beginning of Kotlin or something. uh yeah, so K class has actual code, it seems. So it's not like okay, it was added after the going multi-platform. It was there since long. It's just a Java counterpart of the class. So probably they have added this expect actual thing on a later point of time. Okay. Yes, you can lower down the hand if you don't have any question. What is the actual keyword? Hey folks, why are you chatting? You can just ask the question. So expect and actual are the keyword for the when you are working with the Kotlin multi-platform. I mean, it's not like that. As of now we are not working with the multi-platform, but when the libraries that you are using has support for the multi-platform, so there is this things called expect. So expect means expect is just like your interface. Expect means you define the schema for your class or interface, and the actual functions or actual class will represent them uh, on a different platform. For example, let's take an examples of the UUID. Okay, so generating the UUID on the Java is pretty simple. Something like a UUID dot random UUID dot toString, right? So if I'm building a library on the to generate the UUID, now the implementations of the I can tell that okay, the expect value for the UUID would be string because this will return a string. Now the implementation will be differ. For example, on the Android or on the Java part, you can use this syntax UUID dot random UUID to generate the UUID. On iOS it could be different. On Windows it could be different. So for each platform you will write the actual functions or actual class. Expect means your schema and actual means your actual implementation. Okay, do we need to write this code in every project, or there was a way to write once and use it in keyword? I am not able to clearly understand this thing. If you have a question, please feel free to raise your hand, and that would be a preferred way. And by the way, if someone of you knows the answer and I missed something, feel free to answer it in the chat as well. Okay, I'll continue. And so what we are going to do is now we are going to write the annotation processor that will process this annotation and generate the whole binding code. So let's just go and let's just create and oh my god, let's just create a new module. I'm going to import. I just want to create a new module. Okay. Again, same thing. It's a processor, right? So we will create a Java library. Let's call it a processor, processors, and class name could be anything. Okay. We will write some code into it. Okay, processor is ready. Okay, and we have the build file for the processor as well. Pretty simple, right? So let's do one thing. Let's create a class and let's call it the annotations is generate binding. So let's give it a name something like a generate binding processor. Okay, we will create a class something like this, generate binding processor. Okay, in this code we will write the whole thing, whole code that generate the code using this annotation. Okay, so will we get the recording also? Yes, you will get the recording as well. Yeah, probably if you are in Android community group, because this is where I will share it. Okay. Okay. So to uh, generate the to generate to process any annotations, what you need to do, you need to extend this abstract processor class. This is coming from the java x dot annotations dot processing. So this is the entry point to your annotation processing. This class is the entry point to your annotation processing. And it is asking me to implement few of the method. One of the mandatory is the process method. This process method will process the actual annotation. Okay. Now now what we will do is, it has a four important method. uh, the one is a get supported annotation type, get supported source version, and init. Okay, these are the important methods that this you need to understand. Get supported annotation type, source version, init, and process. Okay, so get supported annotation type means what? Here inside this method, you need to tell the processor that which annotations you are going to process. We are going to process this generate binding processor, right? We are going to use this. So you need to give the fully qualified name of this class or interface. So you need to give it something like a com.rajesh.annotations, and then you need to tell them the generate binding. So basically you need to write something like this. Inside this, you need to write what you need to return. You need to return a set. So you can write a set of, and you need to write something like this. This simply means this processor, that is this class, will process this annotation. Okay, we are only interested to process this annotation, nothing else. कोई extra work नहीं करना है अपने को, we will just process this annotation. ठीक है. Now the thing is, what if tomorrow I go and change the name of this generate binding blah blah blah? Okay, if I change it something like this, then this is not going to work, right? Because it's a static string. So what we can do is we can just refer the actual class itself. So we can write something like a private val generate binding annotation. Okay. So what we want to refer, we want to refer the actual class generate binding. Again, it's not visible because this is inside a separate module, and we are trying the code in the processor module. So in the processor module, in the dependencies block, let's just add the this one. So we'll write something like implementation projects, and we will write annotations. Okay, so now we will be able to access the whole code from this module. ठीक है, अभी I can import it, right? So this variable refers to this class. Okay, so I'll write something like generate binding annotations dot a dot uh, this is what, this is a class. We don't need a class here. See, if you just write this class, this will generate a K class instance. That means for the Kotlin, if you write at the Java, this Java is an extension variable. This Java is an extension variable on a K class that will give you the class required for the Java. Okay, class required for the Java. And this K class is again Kotlin thing, right? So we can just write the class. And what we want is we want a fully qualified name of this class there. Okay, so we'll just write a qualified name, and we will use a this screaming operator, because we for sure know that okay, this is not a null. This this could return a null if it's a anonymous class, or if it returns a null if the class is a local or an anonymous class. But neither it's local, neither it's anonymous. We just created a reference to this class, so we can safely use the explanation operator. This line says the annotation processors that okay, we are interested to process this annotation. The next method is get supported source version. What does it mean? This means which versions of this Java this annotation support. Okay, which version that of the Java or JVM is support. So currently I think it's a JDK version is a 22, right? Or the uh, LTS version is JDK 21. Yes, 21 is LTS. ठीक है. Or so what we will do is we can just write the source version dot, let us say, 5. supported. So whatever the latest supported version that system provides us, we will just pass it. And this annotation support, basically, we want to support everything, Java 6, 7, 8, 9, 10, whatever. Okay. Then this third method called a init. Inside the init method, what you do is you initialize. If you have some, for example, variables here, and you want to initialize them, you can do them inside the init method. Okay, this will give you a processing environment. And then finally, there is this method called a process. This is the most important method because all of the code you will write here. Okay, I'll just, this is what is P0 is, okay, this is a type or annotation. So I'll just rename it annotation, and it could be a set, right? We don't need a variance here, and we don't need nullability as well. Kotlin, the compiler is just being the safe here with the generated code, but we don't need this thing. Okay, it returns a annotation as a set of annotations, and it will return you a rounding environment. So we'll see these things, and you need to return any boolean here. Before we see these things, any question, any concern? Someone has a question. It seems concern. Yes, please. You want to ask something, concern? Oh my God, sorry. I I really need to follow the mic.
Yeah, thank you. So I was asking that every time we have to write a new processor for
Mm,
a particular annotation to get binded,
mm.
or writing just single. So you have written one generate binding, right? So do I have to every time call this function in separate processor, or how will it be? I mean, the process which you're doing for the process part, yes, these three
Mm,
methods. So do I have
mm.
to write it every time when I create a new binding class?
No, no. What you need to do is inside this class, what we will do, we will write a code that will look for all this binding implementation on our application code. And wherever this binding annotations is there, it will generate the code accordingly. So that logics we will write once here, and once this processor is ready for all of your repository class, you just need to write this line, just a single line of code. And this processor, basically, this is a setup that we are doing. This is the setup that will generate the code whenever this annotations is added.
Okay. So it's a
Makes sense?
one-time work is what you're saying. Every time we don't have to
Yes.
do this.
Yes, yes, of course. If it would be an every time, then why would I do this? I'll just go, Hilt, and I'll just write the whole module thing. Why would I do this extra labor? So it's a, yeah, definitely it's a one time thing.
Okay. But like in generate binding, can you open that generate binding once?
Yes.
Yes, here. So here right now we are just have kept one variable as class. If I have to add more things, that also I will write it here only, right? And for
Yes.
those
Yes.
again, a processor will not be required to set up.
No, no. If you want to add more things, you need to go and tell the processor what you want to do with these things. We will tell the processor what we want to do with this thing. So we will write that code here. If you want to
Okay.
add more and more things, you need to tell the processor what exactly you want to do with this thing.
Okay.
Okay.
Yeah,
See, for
that's what.
example, right? So in this example, we want to we are passing type as an interface. So we will tell the processor that whatever the type we are getting as an interface, you need to return this type as a part of this function code generation, right? So
Okay.
that's what we are doing.
Okay.
Okay, and once every things are tied together, the picture will be more clear. Cool. Sharvanan, please. Uh, I think I have. Yes, I have allowed your mic. Can you please quickly ask your questions? I don't want to wait. Cool. I think maybe
Just,
he or
I have a doubt like,
hmm.
why are we creating it in separate modules? Why are we having annotation and processor in separate modules? Can we put both in the same module?
I think I have answered this say twice, maybe earlier in the starting of these
Okay.
sessions, and then someone asked the question as well.
Okay. Maybe I missed
Cool.
it. Sorry.
Yep.
Okay.
That's fine. That's fine. So the basic things is, you keep them in separately because the annotation processes will run on, separate JVM. So
Okay.
you,
Okay. Okay.
the things can run in separate ones.
I got it. Got it.
Okay. Take. Awesome. So, okay, so you see this method returns a set of a string, right? So this process methods will again return a set of a annotation. It will be written in a type element. What is a type element? Type element is, it is coming from the very complex things, right? Java X language model element. But just to understand, the type element is any type that can be represented, example, say interface or class, that can be represent it in the language level. And there is this thing called a rounding environment. So I guess I won't be able to get the documentation here, but rounding environment is something to, annotations run in a phases. So annotation, rounding environment. Let me grab quick graphics if I can get it. Uh, both of these checks are important. No, I don't think there will be a ready-made graphics, right? So annotation processing will process provide an annotation processor with object implementation, so the blah blah blah. So the rounding environment is something, annotations will run through multiple passes. So if there is any error in the one pass, and you can just stop the processing. But that's fine. That's fine. We don't need to just dive into it. Let's just focus on what we want because otherwise we won't be able to finish it if I go and explain everything. Okay. So what we will do is uh, there is this awesome library called, because ultimately, see, what we will need is we will need to generate a file that contains this code, right? To generate the file, generate the write a code that generate the code and store it into file. There is this awesome library from the Square called Java Poet. So it is a Java API for generating the .java source file. Okay. So this code will allows you to generate the other code, and you can write it. It allows you to generate other code and you can write it inside a file. So that is something we will do. Along with it, it has some helper methods and all those things which we can utilize. Similar to the Java Poet, there is a Kotlin Poet as well, which can help you to generate the Kotlin code. The way we are not going to use the Kotlin code is, Kotlin has its own things. For example, if you see these things, to maintain the compatibility, if you see the string from the Java part, it is probably Java dot language package, right? String. I'm not sure, but in Java dot language dot string. But in case of a Kotlin, the string is Kotlin dot string, right? So there is this incompatibility. There are ways to handle these things, but let's not go into it. So for to keep the simplicity, we will generate the Java code using the annotation processor. Okay, here we are writing the Kotlin code, but we will write a Java file that will generate the Java code, and that can be done using the Java Poet library. So let me just go to the processors and let's add this library. So I'll just add it from the version control. So I'll write a libs dot Java Poet. Okay, com.squareup Java Poet, and the version is 1.13.1. Let's just sync in. Okay, this is done. So now let's do one thing. Uh, these annotations that we are getting, let's grab the interface that is mentioned inside this annotation. So we can write something like a well interface equal to type, uh, equal to annotation. Oh, what's happening? This is a private one. Let me just return true false product. Okay, done. So it doesn't show an error. Okay, let's just write it type because this is the type element. So what we want is I want a first interface from this method. So let's say well first interface equal to type dot, not this one, man, type dot interface. Okay, it has these things called a type dot interface. Spaces. Why this thing is not, resolving type is a type element. So there is this get interfaces method, right? Why it's not resolving? We have other type anywhere else. Mm, Interfaces. Uh, okay. Cool. So okay, my bad. So we are trying to access this. This is dependent on this interface, right? But we have a set here. So let's just call this. You know, let's do one thing. Let's get the rounding environment, and from the rounding environment, yeah. So one important step we miss is we want to get elements, all the type elements. So we have a set here. So we want to get all the type elements that has these annotations on top of it. Okay. So we can get this from the rounding environment. So we can write something like a get element. We get elements annotated with. Okay. Which element we want to provide? We want to use this generate binding annotation dot java. We want to get all the elements that has these annotations on top of it. Okay. And then what we can do is we will filter them out. For example, let's say we get a class or a functions or whatever. Okay. We want to filter them out by the class. So class, again, type element is what? It can represent a type or a class or interface. So we can use a filter is instance. Again, it's a Kotlin thing. I'm just using it for, better uh, maintainability, but that's fine. If you don't like it, that's fine. Now, for each of the class that we will receive, okay, for example, this annotation can be applied on a multiple classes, right? So for each of the class, we will run a for each loop, and now we will do something. Okay, we will run a for each loop, and we will do something. What we will do is let's define them in a separate function. So for example, let's call it a generate. We want to generate a Hilt module. So it's a Hilt module with binding. Okay, generate the Hilt module with a binding. So what we are getting here is a type element, single type element. Okay, we are getting the single type element. So we will accept the type element here. Type element. If something just goes over your heads, don't worry, because that's fine. And now for each of the class that we receive, we will just call this function, and we will just pass the type element. Okay. Now the actual code generations can be done here. Let's make it a private. Okay. Now what we got is we just got the type element. So from this type element, we will get the interface that is defined on this annotation. Okay, I think someone wants to join or someone has raised the hand. Uh, just give me a few seconds. I can come back to you. Let's write some code and then. Okay, we'll first get the interface. So let's say, well, first interface equal to type dot interface is okay. So by the way, those who are wondering, the Gemini is completing the code for me. If you are onto the Canary build, you can just have the Gemini in your studio. So we want a type dot interface dot first. If it's a null, let's for the safety, let's use the first or null. Okay. If it's null, then just return if it's a null, see, if the interface inside these annotations is null, then just return the superclass of this implement class. I mean, a type. Then you can just return the type dot superclass. That's fine. Okay. Now we got the interface. Okay. The type is a type mirror. I mean, what's happening? Type is the type. I'll try to keep the thing simple for you. Now, what we will do is we will check the bounding type. Okay, we will check the type that is bound with this. Where did it went? Type that is bound with this annotation. Okay, we'll just get this type, and then we will type. We will get the type that is bound with this annotation. So let's say we'll call it a bound type equal to uh, type name. There is this thing called a type name coming from the Java poet. This allows you to get the type name from the type mirror. Okay, these things are a Java related concept, but that's fine. Okay, we just go the bound type, and if you want a bound type name, then you can get that things as well. But this bound type is what this bound type is this interface. Okay, this bound type is this interface because again in this generate binding we are defining the type. So this type is bound to this class. So the type is your bound type will return your this interface. Okay, bound type is done. Now we can get the name of this bound type. Again, this is represented as a type name. We want the actual string name. So let's say, well, because when we generate this module, we will need the name of this, right? So we'll just get the string name. Bound type name equal to not the toString, man. It's not that easy. Gemini is going wrong. So we have these things called a processing environment. Okay, processing environment coming from the abstract processor. So from the processing environment, it what it does, it basically it provides you a utility method that can help you play with and getting the name of the classes, name of the interfaces, and all those things. So we can get the type utils dot as element and first interface, and then we want a simple name. What we want is we want a simple name basically. Okay. Now it will return a from the type name. It will return me a name. Okay. Name means what? It's a custom data class for this class, and I can just use this name. This will be clear when I write a more code. Okay. I'll stop here. Let's take a questions if anyone has. I guess people has. Sharwanan, yes, please. Arpit, you can raise your hand. I'll get back to you. Sharwanan, you want to ask something?
Sorry, actually, it was raised already and the question has been answered. Thank you.
Okay, cool. Please lower down though. It's not required. Okay. Do we have Arpit? I think he raised the hand and maybe he left it. Cool. ठीक है. Awesome. Yeah. So now what we will do is we will generate this whole thing, right? We will generate this whole thing. So before we generate a class, what we need is we need to generate this method, right? So this code that generate this method is provided by the Java Poet library. Okay, Java Poet library allows you to generate the method, generate the code, generate the interface, or whatever you want. So we want to, I'll keep it side by side. So, that would be easier for you folks to understand the things. There is a hint module. Yes. So what we want here, someone can please go on a mute if you are not talking. So what we want here is we want to generate this method. Okay, so to generate a method, the Java Poet library has something called a method spec or method specification. So let's say method spec equal to method spec coming from the Java Poet method spec. Okay, and then there is this things called a method builder. This allows you to write a method name. Okay, so what we want is we want to generate this method. See, the name will be bind and my repository. What is the my repository? This my repository is the interface name. So we can write a bind and interface is our bound type. So we will just write at the rate bound type. Okay. So what this will generate? This will generate a method whose name is a bind my repository. Okay. Because from here my repository is a bound type is given. Okay. So this method will generate a bound type method with a name bound type. Okay. Now this method needs to be an abstract method, right? So let's just add a abstract modifier. So let's say add modifier. So we will write a modifier. So first we will make it a public and then we will make it a abstract. Java.language.reflex. What's happening? No, I think I have implemented modifier. Uh, yeah, this one dot public and modifier dot abstract, because this method needs to be abstract method, right? So we added that modifier. Now on top of this method, what we need is we need this bind annotation. So we will add annotations on top of this method. Add annotation. Okay, which annotations? We need binds annotation, right? But again, this bind is coming from where? Coming from the dagger. Okay, and we do not have access to the dagger because dagger is not defined as a inside the build file of this file. So this is coming from the dagger, so we don't need a Hilt dependency, right? Let's just go and grab the dagger dependency. So just go to the dagger and let's just get the dagger core. So let me see where is this thing. Yes, this dagger 2.x means what, man? Give me the actual version. What is the version? 2.51, right? So let's just use 2.50. Okay. Implementation pom.dogger 2.50. Okay. Let's just sync it. So we will have access to all the dagger classes. Okay. Now we want to add an annotation. So now this is visible, right? Awesome. Coming from the dagger. Okay. So this is how you see the point here I want to make is this is how you generate code step by step. Now we want to add these annotations on top of this method in the generated code. Okay. So binds.class.java. Okay. What else we need is this method needs one parameter as well. See, this method needs a parameter as well. Okay. So if you want to keep this parameter, you can again use a conjunction like this. But we can do something like this as well, right? Because parameter name doesn't matter. We can just write impl. So we will add some parameter to this method. So using the add parameter and the name. Okay. Okay. We will need to add the parameter. And what is the type of this parameter? The type of this parameter is a my repository impl. That means the class that added these annotations on top of it. So for the type, what we need is we need a class that added this parameter. So we already have a type. Okay, but the type is a type of this type is type element, and here we need a type name or type. So we can get the type name dot get. Okay, there is this get method which allows you to get the type name from the type. So we'll just write a type dot what's happening, type dot as type. Okay, this is our type of this parameter. And what is the name of this parameter? It will be impl or implementation. So basically we want to generate these things using this code. Okay, parameters done. Now we want to return something using this method. What we want to return? We want to return this interface, that is our bound type. Okay, so this returns what? It returns a bound type. Okay, so now what we just did is we wrote a code that will generate this code for us. We wrote a code that will generate this code for us. Okay, now we will write a code that will generate the class for us and add on, keep this method inside this class and add this annotation. Clear up to this point? Any questions, any concern? Hmm. Okay, I guess yes. Cool. So we created a method specification. Now next what we want to generate is we want to generate this class that is a binding module, right? This Hilt binding module. So that is a class. So we will use a, instead of a method spec, we will use a type spec. So let's call it a type spec equal to type spec dot class builder. Let me just get it. Yep. Type spec. So class builder. We want to build a class. It has, these things called an interface builder as well. If you want to interface enum, if you want to create enum or interface or anonymous class, okay, so you can do this thing. Name of this module will be, let's say, again, we will give it name something like, let's say, my repository module, something like this. Okay, again, this is our bound type. So we can use something like what's happening, something like a bound type name and then module. Bound type name and a module. Okay, okay. This will be the name of the generated class. Now, again, let's add. Okay, let's make this class abstract. So let's add modifier. So modifier dot abstract, because we want to make it an abstract class. Okay. Now, on top of it, we want to add this module annotation. So let's add annotation, and again, it is coming from the dagger module dot colon class dot Java. Or I think class is enough, right? Or what we need, class dot Java. Mm, oh yes, add annotation, not annotation. Okay, we added this module annotation. Okay, we added this module annotation. Okay, and we made it abstract as well. Now we need to add this install in annotation. Add annotation. Annotation. Now this is a different. This is annotation. It's not a regular annotation. It takes some argument as well, right? This module was fine. We just wrote it something like this. This bind was fine. But this install in annotation is something that takes another, another, what to say, mm, another, I mean, uh, yeah, it takes another class as a parameter. So in the add annotations method, we will use, just like a class builder, we will use a annotation builder. So we'll use the annotation spec, uh, annotation spec dot builder. Okay, annotation dot builder. What is the name of this? Okay, what is the name of this thing? It's going to be, it needs a class name. So this is install in annotation coming from the dagger.hilt annotation package. Okay. So we want to get the class name that is inside this dagger.hilt, and the name of this class is install in. We want to get the class name type for it. So we'll write a class name dot get. Okay. And you can pass package name and a simple name. So package name is the dagger.hilt, and what will be the name of this class will be install in. So we will grab it something like this. Now this class need one member, right? So we will add one member on top of this annotation using the add member. Okay, so this add member need a name. It needs a name and format and varag. Okay, so if it's a Java class, uh, it would be something like this, singleton dot class, right? If the generated file is a Java file, if this is a Kotlin, so we use this syntax. But if it's a Java file, then we would write something like singleton dot class, right? So the we want to, okay, this install in has this value member, right? So for this value member, we want to provide this thing, and the format is a class name dot class. Okay, so format is the class name dot class. So class could be any generic class name. So it could be using the dollar, we can say t dot class. Okay, this is the syntax this Java file will follow, class dot class. And now we will give the actual class that will replace this t. Okay, so again, class name dot get. Okay, again, this thing is coming from where? Dagger.hill.component, and the name of these things is a singleton component. Okay, we added a these things on top of it, right? And this builder, and we will call the build method. Okay, so now इतना यहाँ तक का हो गया अपना, ठीक है, यहाँ तक का अपन ने कर दिया. अभी इस क्लास के अंदर ये मेथड हमें डाल देंगे जिसका कोड हमने ऑलरेडी लिखा है. So we will add a method. Okay, we will add a method. So method spec dot build. Okay, we'll build the method. फिर इस क्लास के ऊपर you can add public modifier just like this. So let's just copy it, something like this. Okay, now you need to add the originating element. Okay, and originating element means from add originating element. So this allows you to track down the things like from where these things, what is the origin of this class builder. So let's give it a type, that is type element, and then we will finally build it. So at this point of time, what we did, we created a method specification, type specification, that is class specification. Let me just give it a class spec. So, it would be easier for you. Class specification. Now we will tell the Java Poet library to generate a Java file for us. So we'll write something like a Java file equal to, Java file dot builder. Okay, what will be the name of this file, what will be the package name of this file. Okay, so again we will use the class name dot get, and we will just pass the type and dot get the package name. So basically, for even for the generated code, we want to keep the same package. So the generated code will be inside this package, inside the generated folder. I'll show you. And what you want to write inside this Java file, we want to write the class specification. Okay, and then finally you can use Java file dot write to. Okay, and processing environment dot filler. Filler means it will write the file for you. Okay, so this is something we did. We just wrote a code, we just wrote our processor, and this will do the things for us. Now there is some error, it seems. Let's see what the error is. Mm, oh yes, okay, okay. So we successfully wrote our annotation processor. Okay, we wrote our annotation processor. Now what you need to do is you need to, because see what's now what you need to do, you need to declare this annotation processor. You need to go and declare your annotation processor, because I mean Gradle needs to know that okay, someone wrote this processor, right? So what you can do is, let me show you the manual way first. Annotation processor. Uh, will do maybe. Uh, Let me show you the manual ways to do this thing, and then I'll show you the automated way. There is the meta.inf, meta inf. What the hell is that? Oh yes, okay. So now adding a process class path to jar. So what you need to do inside the source main and resource folder. So inside for this annotation processor, this is if you go and see this project. So this processor source main, and inside the main there should be a resource folder. Okay, so let's just create a new folder, a new directory called a resource. Okay, inside this let's create a directory called a meta.inf, sorry, meta-inf. Let's create a directory meta-inf, and inside this let's create a service directory meta.inf, and another directory is service directory. Okay, inside the service directory what you need to do, you need to create a file, and you need to tell the Gradle, you need to tell the Java that okay, we wrote a processor that can process this annotation. Okay, we wrote this thing that can process it. So inside this services folder, let me just grab the file name as a fully qualified name. Okay, Java dot, yeah, the name should be this one, Java dot, yeah, this is the mandatory. Okay, you cannot change the name. So there is, you need to create this file called javax.annotation.processing.processor, because when the processor will be processing any annotations, it will check this file at this location. It's a mandatory. Here you need to provide your fully qualified name. So this is our annotation processor. So the fully qualified name is com.processors.generated binding processor. This is the all things you need to do. Okay. This Java annotation processor will look into this directory and it will get to know that okay, this guy want to register some processor. Okay. Now it will get to know that okay, these processors can process this annotation. So at the compilation time, it can process all the generate binding processor. Okay. Now to make this processor available in our application module, we need to include it. Okay, in the application build file we need to include it. So we'll write something like a process. What is the module name? Processors, right? Okay. So at the compilation time this will process it, but the type of this won't be, type of this won't be implementation. It would be a KAPT, because this is a processor and we want to process our annotations via this processor. So we need to pass it to KAPT, that is Kotlin annotation processing. I believe all of you knows what KAPT is, right? So the type of this processor would become a KAPT. Okay, KAPT project and this. Let's sync it. Let's see how it goes. And let's just write a Hilt module and okay, something like this. Okay, let's do one thing. Let's just comment the whole code. So now Hill should give us an error, right? Let's see what happens. Let's run. Let's see if something is generated at all or not. Oh, awesome! See this even without this code, Hilt is not giving us an error. Let's see. So that means our processes are working. Awesome. So let's see if we have something. So in the app, let's go to the build folder. In the generated, into the source, into the KAPT. I'll tell you. Inside this generate binding processor, what we told this Java file to have the same package name. So the Java poet created a same package name com.rajesh.code generation. Inside it created what is the name of the file we told it to create? Something like this module, right? Bound type module. That is my repository module. So you see, it wrote the whole code. It added a module, this module annotation, and it added install in, then singleton.class, and then it created a public abstract class using this modifier. It created a class name as a repository module, which is something we defined here. Then it created a public abstract of function. This one, public abstract, right? Bound type. So bind my repository. And there is this IMPLC. It is coming from this one. And it has a bind annotations, which we just added here. So the Java class is generated for you. Okay, so now you don't need to specify, you don't need to create a modules each time. So your annotation processing was a successful. Your annotation processing was a successful, and you just created your first annotation processor that is stored inside the generated source KAPT, this package name and my repository module. So this is how it's working. Hilt is not giving you an error, even though there it is. Yeah, even though I have wrote nothing in it, because at the compilation time, my generated this file and Hilt is able to, see this file. So Hilt is not giving me an error. If I don't write it, then Hilt will give you an error. Let me show you. Let's say we disable our processor, something like this. I think let's keep just here. So would be easier. So let's say from the application file, where is the application file? And there is this build file. Let's just disable our processor. Okay. That means no generation should happen. Now let's try to run this. Yeah. So Hilt is giving me an error, right? Because it is missing the bind for this interface, and implementation. Because now the generation processor is not in the action. So the file was deleted. So one thing you need to know is all the files will be deleted and recreated on each compilation time. Okay. Now if I again add the processor, the file will be created at each compilation time. the file will be created, and Hilt won't give you an error. Okay, this is how you just create your first annotation processor, how you generate the code. Before I go on to making the things automatic a bit, any questions, any concern on what we wrote? Any questions on this technology or anything? Awesome. Cool. So let's do one thing. Now the thing is, we wrote the whole these things ourselves. I mean, let me just go here and resource and blah blah blah. Maybe when you use the annotations, you don't have time to generate these files and add these annotations, and you could make an error, something like this. Okay, it's a possible that you could make error something like this, or you uh, you know uh, do something like this. So these are the errors, and you need this labor. We don't want to do these things. We are developers. We want to simplify the things. So what we will do is, Google has a lot of repositories that in the Google Auto repository, Google Auto. See, I think I bet none of you have about it. So it is a collections of the source code generators for the Java. It has the three things: auto factory, auto service, auto value, and a common. What we are interested is auto service. What it does, it provides a configuration file for the service loader. So when you create this file, the Java service loader will comes into the picture, and it will read this file. Okay, coming from the java.util.service loader. So this will comes into picture. It will read this file, and it will get to know that, okay, there is this processor called generate processor. We want what Google allows you. Google says that don't do this labor yourself. Okay, don't do this labor task yourself. Just use our library, and we will generate these things for you. Okay, so you need auto service library for this to generate it. Okay, so I already added it, if I'm not wrong. We are yet to edit. Let's just edit implementation form dot google. No, we don't need a Google compiler, so we'll just use the libs dot google libs dot auto. Yep. No, there is my auto. Yes, auto service, right? Auto dot service. Let me rename it to something like Google Auto Service. That way it will make more sense. Okay, libs dot google dot auto dot service. Let's think it. Let's just grab the service, and awesome, we have it, right? So now what we will do is, for our annotation processors, we will just annotate processors with the auto service. To generate the files for the processor class. Okay, this java.annotation.processing. We want it to generate the processing file. Now we don't need all of these things. Okay, I can just remove this thing. Let's just. I think this was deleted, so it's not showing. But now I don't need to do these things. Okay, I don't need these things. So the auto processors will generate these things for me. Okay, this file, and now I don't need to go and write this thing. I'll see. Let me just run it. You see, now our processor is a gradle task as well. See, now it's a separate satisfying feeling to see your processors as a compilation task. mm, for missing binding usage, because what we just did, generate binding, binding, and yes, generate binding. It seems Google did not generate it. Let's see what we missed. Yes, we just added the implementation, but we need to, we need to add the uh, uh, compiler dependency as well. I mean, annotation dependency as well, something like this. And this could be a compile time only instead of the implementation. So we need this dependency only at the compilation time. And yeah, we don't have a kapt here. Let's just edit Kotlin kapt and sync it. Should be good now. Okay, let's run it. Let's see what happens. Awesome. It's working, right? See, even if we have not defined it, because this auto processors will, Google Auto Service will define this file for you. Okay, it will define this files for you. Maybe you see the project view, you will just grab the file. Okay. Now we are not explicitly need to define it, and this thing will do it. Another things you do here is you can leverage these things called a Gradle, what we call incremental compilation. So incremental compilations is the concepts of the Gradle that says that if the part that is, if the input that is required for your task is not changed, I mean, you just compiled your application, and now whatever is required for your classes is, if it's not changed, then Gradle will completely skip this process. So it can save us time, right? So that is the whole concept behind the incremental build. I'll just share it and then we will implement it. You know, you can go and read more on the incremental build type. Okay, so to add the incremental support in the build, you need to define some files, but again, we don't want to do this manually. So there is this things called a Gradle incap helper. There is again this library called a Gradle incap helper. Incap means incremental annotation processing help. Okay, so this I'll just share it as well, so you can just go have a look. Mm, this library into my annotation processor. Sorry, there is a build file. Yep, just like compile only. I can have it leave dot what I named it incap dot 4. 4 would be your compile only dependency, and the processors would be leave dot incap dot processors would be your kapt dependency. Now once the syncing is done, what you can do is you can add this at the rate increase. Maybe hey, sync is done. Let me check in the processor. I guess sync is done, right? Mm, why we are not able to let me just rebuild the whole project. Mm, what is this? Uh, processors KAPT could not find in-cap processor. Uh, okay, in-cap processor. So let me see if I messed up with dependency. With Gradle, it's a net.ltgt Gradle in-cap and in-cap, and then this in-cap and then in-cap processor, right? I guess it's them. In-cap, in-cap, ltgt Gradle in-cap. In-cap version should be 10. Why it's giving me an error? Could not find processor 1.0.0. Oh my god. Yep. 1.0.0 should be. Because you see on the release page it is 1.0.0. That's why it was giving me error. It was not able to find it. Okay. Now you need to add these annotations called a incremental annotation processing. Incremental annotation processing coming from the incap library, and you can provide the increment like you can provide the type. So there are multiple types. So uh, incremental annotation processing. So type dot isolating. Isolating means uh, there are multiple types. For example, dynamic aggregation, isolating. So isolating means our task is isolated from others. We don't need to depend on other tasks that can give us the inputs and blah blah blah. We don't need all of these things. We are just isolating on our own. Okay, so that isolating is again part of the uh, concept: isolation, aggregating, or dynamic. So these are the annotation processor type for the Gradle. So now this will use the uh, incremental build concept for the Gradle, and it won't again recompile if the value is not changed. So this is done. This is something we have seen, and the now the same thing. I'm not like whenever you create a new interface and new repository, you just need to add these annotations, and the task is done. The all the codes will be generated. So the use case for this is a limitless. Okay, annotation processor. You could use it for whatever you want. You want to generate say provide method for the Hilt, right? Or you want to write say generate method, or maybe you want to uh, get some data store or get room class for you, or any sort of thing. Then you can use annotation processing, and these codes will really help you. So go to your code base, dig down into your company's code base, see what can be automated, because we really want to automate the things. We don't want to do the manual task. See what can be automated, and then write the annotation processes for them. So this will increase your value in the whole team. Like if your team will find out, they will be like, oh, this guy is very talented. So try to do this sort of things, and it will be helpful in your career as well as to enhance your knowledge as well. That's all for today's session. I'll coming to the questions. If anyone has, please feel free to raise your hand if you have a question. Sharwan, and yes, please.
Yes, I'm wondering like with this annotation processor, can we create a whole screen? Like what I'm wondering is the AI thing is creating a threat to our jobs. So anyway, with this, can we create an entire screen or some way can we automate it?
Yes, yes. So this helps you to generate the code, right? So
Mm.
whatever the code you want to generate, as long as it's a Java or Kotlin code, you can generate it. You have method specification, you have a class specification, you have interface specification. So you can generate any sort of Java file. And this Java Poet is a very rich library, so you can make use of it.
Okay.
Okay.
So in
Keep
that case, maybe if a team of engineers extensively work on this thing, like with some simple configurations, we can create a whole app, right? Like what I mean
or
is,
right. So what you are doing, if you are doing some repetitive things, let's take an example of your app configuration. So if you have
mm,
some sort of app configuration that you just need to change some value for some other app. So yeah, you can write annotation processes, and that can handle this for you.
okay, great, great. Thanks for the session. It was really useful, and thanks for the efforts that you're putting in.
Yep, my pleasure. Cool. Any more question? Anyone? Just raise your hand so I can unlock your mic. Thank you, Ganesh, for application. Yeah, thank you, everyone. I guess no more question. So that's all.
Maybe
Yeah.
I have a
Yes.
suggestion like in the upcoming sessions if you have any plans like this topic is really helpful but
Mm,
I feel like only in recent times like the Android community is being like getting upgraded to like CACD all those things so it will be really helpful if you conduct a session on CACD all those related stuff so that many people will benefit from it.
mm-hmm. All right, that can be done. Yeah, CSED is again a good concept. Let's see. I'll always try to have the sessions, three sessions like this. If I get the time on, I'll take the CICD, or if some other concepts like based on the. I usually do this thing. I send a voting in the community, and what the people want most, I take the sessions on. So yep, maybe we can take the CICD or whatever. Who knows? But anyway, whatever it is, I believe it will going to be helpful for everyone. Thanks for
Yes, thank you,
permission.
thank you.
Uh, okay, someone wants to write something. Could you share the community link to join? Yes, definitely. So, uh, I mean, give me a sec. You just go to my LinkedIn and you see uh, there is this post. Join our free WhatsApp community. Right? It's a feature post. So these are the uh, two things you can have, and the first community is a full, so probably you will need to join the second one, and these are the things you can do. Anyways, if you miss this links after this session, just go to my profile and just go to the first feature item, and it's there. Okay, Spring Boot is something, it's a default. We have removed it. Don't worry, I'll just remove it as well. But you just go to the links and you can join the off topic and the primary groups. Okay, thank you everyone. Thank you for your efforts as well, and I really appreciate who stays up to this point, because just joining is easy, but staying along is it requires a lot of effort. So thank you everyone for putting the effort, staying with me, and hopefully, you know, we will I'll come up with great sessions in future, so it will be helpful you as well, and probably I'll get to learn things from you as well. Thank you. Have a good night. Take care and bye bye.